He's already been dead and it's messed with his head. It's John's post-life crisis.
Welcome to John's post-life crisis. I am John Johnston, founder and guy who started cornnation.com, your Nebraska Cornhusker site of things that aren't football sometimes, and this is one of them. There are coronavirus vaccines coming onto the world, to a place near you in the next few months. This is a big development, and I brought back Dr. Stuart Weston to talk to me again about these vaccines. Dr. Weston is a research fellow at the University of Maryland School of Medicine in Baltimore, and he's been studying coronaviruses long before we even heard of them. So how are you doing, Dr. Weston?
Doing very good, thank you. It's nice to be back talking to you and hopefully spreading some good information about these vaccines.
So there's a number of them, but there seems to be two that are kind of at the forefront. One by Pfizer and one by Moderna. God, my English in the last couple of days is terrible. I don't know anything really about how vaccines are developed. I don't know. I just take them if they tell me to. I'm one of those guys.
Sure.
But I'll tell you what, let's start with, you do research on this stuff. Months ago, we went into lockdowns. It seems like the death rate has dropped significantly. It seems like we've learned a lot more on how to handle this thing. But can you tell us, what have we learned and what do we know right now that we didn't know, let's say, 5 months ago?
Well, I think what we've learned with respects to the death rate dropping, I'll just take that one, is in that initial wave when we were first hit in sort of springtime, since then we've learned how to better treat the patients. So the healthcare workers who are dealing with the people who have the most severe disease in hospital, they've worked out a lot of things that work and a lot of things that don't. So now they're much more equipped to deal with patients. So for example, ventilators were used quite a lot at the start, but quite early on, it was found that they were actually exacerbating things and not helping in the way they should. So they were being used when it wasn't necessarily essential to use them, and that was making the condition worse. And those people were then going down and dying. But that was rapidly learned by the healthcare workers. So they stopped using vents unless it was absolutely essential because those people just couldn't breathe. So things like that. There was another example of proning people. So rolling them onto their stomach instead of having them on their back helped with the breathing when they were suffering from low oxygen. So all these little things that have been learned by the healthcare workers mean that people who develop COVID-19 and have to be hospitalized are now getting better treatment because now they know how to treat them better. So obviously that means that death rates are going down. On top of that, hospitalization is slightly different as well because the demographic has changed for who's being infected. So during that initial lockdown and that initial spread, a lot of the death and the hospitalization was in the older age groups. And of course, we also knew that there was a lot of silent spread of the virus, so people who don't develop symptoms, but we didn't have enough testing to see all of those cases. Testing's gone way up. So now we're seeing many more cases, and we're seeing a lot in sort of my age range in the 25 to 35 kind of groupings. And they're also the people who are largely responsible for this new wave because they're all going into bars once they opened up and restaurants, and they're socializing and all these kind of things. So it's this split between a different demographic of who the main bulk of infections seem to be in, combined with the better treatment in hospital that's responsible for this sort of changing thing we're seeing.
So the two vaccines, my understanding, these are, I hate to go here because my brain's going to explode, but I think we want to cover this anyway. One is they're both RNA-based vaccines, and this is different than a viral vector vaccine. See, I've done some reading. I can say those things, but honestly, what I understand about them is this. We'll see how good this is. A virus is like a protein wrapped in genetic material.
It's protein wrapping a genetic material. You said it almost the other way around, but yeah, the genetic material is inside protein. So basically there.
And the difference between these types of vaccines are how they attack the virus.
Not quite. The difference between them is how they train our body to attack the virus.
Oh, Mr. Semantics. I tried real hard.
It's important. Those semantics are important.
Okay.
So I'll give you my description of the differences. And I just want to say as well, so we're saying about the Pfizer and the Mrna vaccines. I also want to give credit because the Pfizer vaccine was developed by a German company called BioNTech. So it's the BioNTech Pfizer vaccine, just because Pfizer are the ones who are funding all the clinical trials and the distribution, but it was actually developed by BioNTech. So I don't want them to get swept away. Whereas Moderna did all their stuff and get a lot of funding from the NIH. That's how they're doing all their clinical trials. So yeah, you're spot on that they're both RNA-based vaccines. And so I'll just do the little step back into biology 101 to explain how that works. So humans and all life forms we see are DNA-based, so deoxyribonucleic acid, DNA. That DNA encodes the instructions to make all of the protein, and everything that you see is essentially built through protein. The way that the DNA gets made to protein to produce life is through an intermediate of RNA. So it goes DNA, makes RNA, makes protein, okay? And specifically, the protein making RNA is called mRNA. So this is messenger RNA. And these vaccines are mRNA-based vaccines. Now, viruses themselves are these really cunning parasites where they just take over every life form on the planet. So every life form has viruses, and they use what that life form does naturally to make more copies of themselves. So you have viruses that can be DNA based. So then they just go in and they trick your body to think it's its own DNA, and then they make more copies of that DNA. They make the protein that makes more virus. Or they can skip a step and they can just be RNA viruses, which is what coronaviruses are. So coronaviruses are just made up of RNA, their genome. That genome gets into a cell. The cell thinks it's its own RNA, makes the proteins from it, not knowing it's copying viral material, and then produces more viruses. So they just completely parasitize our cells to copy themselves, and our cells aren't smart enough to really know that that's what's going on. Okay, with me so far?
Yes.
Good.
Actually,
so,
I went to Guardians of the Galaxy number 2, where he says, every life form wants to replicate itself and grow.
Exactly. And that's what viruses are. That's all they want to do. If we can subscribe that kind of desire to do anything. But so yeah, viruses like coronaviruses are just made up of RNA. That RNA goes into a cell, it copies itself, and it makes all of the proteins that make a coronavirus, like SARS-2, which is about 30 or so proteins, let's say. The way these vaccines work is they strip away all of the parts of the virus, apart from the one that stimulates our immune response. So when we talk about antibodies that we make against the virus, SARS-2 virus that causes COVID-19, those antibodies target the spike protein, which is the bit that sticks out. So when you see all the drawings of coronaviruses, those little bits that stick out, they're called spike. That's the only bit that our immune system really sees of the virus. So that's the only bit it can attack. So the antibodies we produce bind to that spike protein. And by doing so, they block the ability of the virus to infect a cell and take it over to make more copies of itself. So what the vaccines have done, again, stop me if I'm losing you at all, but what the vaccines have done, they have just got the RNA to make the spike protein and nothing else. So they've stripped the virus essentially down to the one part that triggers our immune response. Okay. So that RNA then gets put into a human through injecting them with the vaccine. The cells produce the spike protein similarly to how they would if a virus was there, but only the spike protein, so nothing that causes damage. Our immune system sees that spike protein, mounts an antibody response, no damage because there's no virus, but you have the antibodies. So then if the real full virus comes in, you've already got the antibodies there. You can make more antibodies that can then protect you. And that's essentially how these RNA vaccines are protecting.
So one big concern people seem to have is that, you're not injecting people with like a dead form of this existing virus or a living form that's been like, I don't know, cut down or minimized. That's not happening here.
So it's not that killed form of a virus, which is sort of the classic thing you think of with viruses. So for instance, there's influenza vaccines that are made that way by completely taking a virus and making it completely inert by destroying it so that it can't do anything, but it's just there as a ball of protein and fat that the immune system sees. So those vaccines are super safe because they can't cause any damage. There's nothing that virus can do. It just goes into the body sees it. But as I was saying, these vaccines, they have essentially stripped away all the components that can cause any kind of issue to you, because it is just about that one protein being produced. So just that spike protein being produced means that there's nothing else there that's viral. So there's no damage that can be caused except your body mounting an immune response to that one viral protein.
So this sounds really nice. I mean, it does.
Yeah, it's great. And so mRNA vaccines, it's been sort of said around a lot that we've never had a licensed mRNA vaccine in humans. This is a completely new technology, things like that. And that's largely come down to just the fact that we've never been able to fully test them. So other ones have been produced. So there was one, I believe, for Ebola. I think they've done ones for other coronaviruses, but there was never the chance to actually test if they were safe and effective. Well, safety is okay to test because you just put it into people and see if they have any issues. But to see if they're actually effective, that was hard because the viruses that are spreading, and we have vaccines too already, there's not much impetus to make new vaccines unless they're terrible vaccines, which most of the ones we've got are good. Otherwise, we wouldn't use them in the first place. And any new viruses that emerged, they died out before we could fully test them. So like Ebola in 2014, for example, had that massive outbreak, but then it went down before we could fully test things. So this is the first time we've really been able to properly assess this new technology. And so far, it's looking really good.
Okay, there's two things there. And I hope my train of thought stays intact well enough for me to remember what they are. New technology always scares everybody. So when you say this is new technology, that sounds like, oh my God, it's going to turn people into zombies. That's one thought. The second thought is this. When we first talked, we talked about the vaccine being the end game to this virus. Sure. We also talked about the fact that it would take at least a year to 18 months. And this is way ahead of that schedule. A lot of people are concerned that, well, they just rushed this through without testing and it hasn't gone through trials and there's going to be side effects. That's where I want to go, because that's the part that has, they announced a vaccine, and here's my sense. I sense a lot of people have way more apprehension about this than excitement. And I'm astonished by that in a way, because you look at this and you go, this is our path to having a full college football season and a full college basketball season and going out to bars and restaurants with our friends. And there are massive numbers of people who are like, I'm not touching this stuff. I'm never taking this stuff. I know I said a lot, but let's start with, is this rushed?
Well, so that year to 18 months time frame we talked about before, that was always based on when we first started to be aware of this virus spreading. So that was always from around January, February time. So we're not that far ahead of the 1 year mark in terms of thinking we'd have vaccines that were getting close to approval. That sort of 18-month window was always, also the 12 month to 18 month was always when we thought we'd start to see vaccines going towards getting licenses for use outside of trials. And that's pretty much exactly where we are. What's sped up the development of these vaccines is the fact that cases are massively spiking. So to test if a vaccine's safe, you actually need the virus spread. So coming back to what I was saying about the Ebola example, if the virus isn't spreading, you can't work out if it's safe or not, or so effective or not. You can work out if it's safe because you just see if people develop bad reactions, but you can't work out if it's effective if people aren't being infected. So that weird silver lining to the fact that we're having these spikes in America, in Europe, and all the places they're testing these vaccines means we get more data more quickly about whether this vaccine is protecting the people in the trials. So we're kind of just about in the time frame we expected. And again, I'll stress that this, at the minute, the Pfizer BioNTech vaccine, they've just, I think today, submitted the paperwork to the FDA to get the emergency usage authorization, the EUA. That allows them to start putting it into people outside of the trial, but that doesn't mean it's going to be widely available. It's going to take a really long time until, well, it's going to take most of next year until these vaccines are actually available down at the CVS or Walgreens or wherever you go to get your vaccine. So we're still kind of in the time frame. Like I say, I think we're a little bit ahead, but that's because we hoped that we were going to get this under a lot more control than we have. The other thing that you've raised about the trials, so I'm saying outside of trials, they are doing all the trials. So these vaccines have gone through their phase 1 trials, making sure that they can be injected into people and they don't cause any rapidly noticeable effects. So that was a small number of people, probably under 100 people get it the first time, just to be like, is this safe? Do they develop anything? Bless those people who take that. It's a risk, but we can't do it without people doing that, right? I credit to them. So they got that, and those people were getting that back in probably March, April, May kind of time. So they've been assessed this whole way through, and there's no evidence of any long-term negative impacts for those people. So that was all positive in phase 1. In phase 2, it was ramped up to more people, so probably thousands of people at this stage. And those people, again, got the vaccine or a placebo at that stage. And again, looking for safety, seeing if they developed anything, with an eye towards if there was protection. So at phase 2, you're mostly looking at safety with a higher number of people, but you're also looking a little bit if you see that the vaccinated versus placebo are protected. And again, those people were probably in summertime. We're still seeing no long-term negative effects in those people. And what we're hearing about now is their phase 3 trial. So this is, again, ramping up the numbers of people. This, for Pfizer, I think they have about 44,000 people, and that's divided evenly between vaccine and placebo. So that's 22,000 people who received the vaccine. And now we're looking to see, do they develop less or fewer cases of COVID-19 versus the placebo group? So this is a lot more about efficacy, but also has the safety. So they're still being monitored for any kind of negative effects, whether they develop anything serious right after they get injected and for the weeks and months after that. So constantly, there is a constant assessment of whether this is safe. And in terms of that, the data that's been released from both Pfizer and Moderna, it's pretty comparable. It seems like people are only developing really mild stuff, so pain at the site of injection. So that's a reportable side effect. I put that in air quotes for the people who are listening. We're on a video, but in air quotes, a side effect is pain at the site of injection. I don't think I've ever had an injection that hasn't hurt me a little bit. So that's a side effect. Then there's things like developing a bit of a headache or a bit of fever, but the fever is your body mounting the immune response. So that's actually a good sign, as long as it's only short. And it's a couple of days. There's a bit of fatigue for a few days, but all of these things are only occurring at under 5% in under 5% of people. So it's really low numbers of really mild things. So it really does look safe at this stage, is the point I'm trying to make there.
Right. So when this comes out, who's gonna get it first? I mean, you'd think that it would go to the people that are the most exposed, and honestly, the people that we need the most, which are healthcare workers and people directly involved in taking care of those of us who are being hospitalized for this, right?
Yeah, exactly. So both companies have come out with numbers of doses that they think they'll be able to produce by the end of 2020 and by the end of 2021. So Pfizer have come out to say that they think they can make 50 million doses by the end of this year, and Moderna say 20 million. By the end of next year, those numbers are 1.3 billion and 1 billion for Pfizer and Moderna, respectively. Now, you need 2 doses of these vaccines. So that works out to 25 million and 10 million this year, and then 650 million and 500 million next year. So there is a limit, because even though over 1 billion doses of these two vaccines is a lot, the world's population is nearly 8 billion. Right. So there does have to be prioritization, to the point you're getting at. The companies are going to prioritize who get these vaccines. And it is going to be, the frontline healthcare workers, because they're the most at risk of contracting this disease. And they're the ones we don't want to get sick, because obviously if you take down the healthcare system, that's got huge knock-on effects. The other people who, sorry, go on.
And I think it's important to note that you'd have to consider, this isn't just healthcare workers in America. This is healthcare workers in India, in the Philippines, in Malaysia, Madagascar, all the healthcare workers around the world. So this isn't like Pfizer developed and paid for a vaccine to be used in the United States. We have to worry about the entire planet here.
Yeah, exactly. So that's why I brought up the world's population when I was just doing my calculations, because these are going to go around the world. And I forget the exact numbers, but America does have an agreement with Pfizer and Mrna for the number of doses they'll get this year. So I think it might be something like 10 million doses of the Pfizer vaccine, although I could be wrong. But you can find the number of doses that they've agreed upon for this year, but that's only, let's say, 10 million of the 50 million. So, and that's only 5 million people who can get that vaccine in America. So as we're saying, what that means is it prioritizes, and they're going to give it to the healthcare workers, and typically the healthcare workers are on the younger side as well. So if, really big, if there are some potential health side effects that we haven't picked up in these trials, those healthcare workers are the ones who are going to be better equipped to deal with it than, say, the elderly or those with severe health conditions. So obviously there is always going to be that concern about the safety as much as these trials are being done. But the thing is, in the trials, they do have underlying health conditions. They do have the elderly. So they're going to keep monitoring those. But as they start to roll it out, it will be in the healthiest and those at most risk of developing the disease, who we don't want to get sick. After that, it will start to roll into those who are at most risk of severe disease. So those over 65, for example. And what was great with Pfizer's announcement on, it's this Wednesday. I keep losing track of time with these things. On Wednesday, Pfizer announced their 170 people and their 95% efficacy data. In that, they said that there's no difference in that efficacy across age and across race and across ethnicity. Wow. So even in the over 65, they still had 94% protection from their vaccine with no adverse events, so no severe side effects from receiving the vaccine. So it really looks like it's actually working in that population who are at most risk, which is really great to see. So it's looking very promising, but exactly as you're saying, it's going to be a slow rollout to those who need it the most and those who are at most risk of contracting the disease, healthcare, and then those with health conditions.
So in the meantime, while all of that is happening in the background, when we first talked, we also talked about treatments. The treatments are getting better. So while this virus continues to roll around, and you also said in that first conversation that it was a weird virus, and that have they done any better at actually figuring out who it affects the most?
Yeah,
that'd be you. You would be they, wouldn't it?
I guess so. Yeah, I'm part of the they.
Yeah.
So yeah, we've basically just really solidified the ideas we had back when we last talked. That those at most risk of developing severe disease are the elderly and those with underlying health conditions. So be that diabetes, obesity, cancer, lung conditions, all those kind of things that put your health at a lower level, let's say, they're the ones who are at the risk of severe disease. There's a few other things that have come to light. So, for example, they found a group of people who have mutations in part of the immune system and don't mount a proper immune response that was unknown before, but they're in the severe groupings. So all the kind of things you might think of that would put you at risk of a severe infection seems to hold true. So right now it's just kind of following the trend and just solidifying the data that those most at risk are those you'd expect to be. But of course there are the outlier cases where the 25-year-old who runs marathons drops dead from COVID-19, that we don't know why, but there's always going to be outlier cases like that. And of course, the fact it's an outlier doesn't mitigate the loss to the people who lose that person, of course.
Right. All right. The other things that stuck with me is from that first interview was we talked about the fact that this is a very virulent strain of coronavirus. In other words, it's very contagious, easily spread. And obviously we've seen that with all of these ups and downs and continuing, whatever. Yep. You also said that it isn't very deadly, compared to the other strains of coronavirus. We know, I mean, if you don't know this, if you're listening and you don't know this, you have to have your head under a rock. Not living in a cave, you literally have to have taken a big freaking rock and put it on top of your head. We know that we are going to have more pandemics. We know that we're going to have more strains of viruses. So, there were people when I asked for questions for this that asked, do I have to get a different flu shot from this every year? And the answer would be yes, because this is going to change as time goes on.
Yeah. So with respects to, I guess I'll take the first bit about the severity, the death rate of this virus compared to the others. So yeah, it's spot on to what we were talking about last time. The two previous severe coronaviruses, SARS-1, the original SARS, and MERS, Middle East Respiratory Syndrome coronavirus, they killed 10% and about 35% respectively. This virus seems to be hovering around 1% or lower. And the difference in why this spreads much more easily is the fact that you get the people who don't develop symptoms and they spread before they develop symptoms. The other ones you only really spread at the peak of disease, and therefore it's much easier to isolate people in hospitals or at home and stop them spreading. Whereas this one, you can be walking around with it for 10 days without knowing you've got it and give it to all the people that you come into contact with. So that's why this one is different. We don't know why that's the case. There's some ideas, but it's not really clear why this spreads when people don't have symptoms versus the other ones. But that's ongoing research that we'll probably learn eventually. And then in terms of the vaccination for this and the question of every year, that one remains to be seen. That one's actually going to be a bit interesting to think about and look at, because with flu, so flu is the comparator, that virus mutates very rapidly. Excuse me. So every year that virus is mutating and changing, and it mutates enough that it can escape the previous antibodies that were produced by the previous vaccine. The difference with coronaviruses is they don't mutate anywhere near as rapidly as flu. So the reason for that, just as for anyone who's interested, when the viruses copy their genomes, they make mistakes in the copying process, and that mistake is what makes a mutation and what changes the layout of the protein so that the antibodies can't recognize it. So flu makes a lot of mistakes when it copies its genome, and therefore the proteins it produces are different and can't be seen by our antibodies, which is why we then play catch up with a new vaccine to target that new virus. Coronaviruses are able to proofread their copying. So if they make a mistake, they can actually go back and correct that mistake and keep doing that until they copy their genome, not perfectly, but closer to perfectly than flu. So they don't mutate anywhere near as rapidly because they can actually correct the errors. And we humans do the same thing. So when we copy our DNA, we proofread, we make sure there aren't mistakes. And if there were, we'd all be, well, single cellular life forms still. We wouldn't be humans if we couldn't do that. So coronaviruses just generally don't mutate as rapidly as flu viruses do. So therefore, there is a hope that we may not need a new vaccine every year, because the virus may still be pretty much the same as what we saw before. The antibodies can still bind to the spike protein because it hasn't changed. I guess the bigger concern, though, is how long-lived those antibodies and that antibody response is. So, of course, there's these stories of people getting reinfected. They've had the disease once, they get reinfected. There's stories of antibodies waning over a period of 6 months and things like that. So that's more the question, is how long do the people who get the vaccine maintain their ability to mount an immune response? And that may only be a year. So the reason we may need a vaccine every year is more about our response rather than the virus. In this case, it's different for flu, but for this one, it's possibly more about our ability to maintain that ability to produce an antibody response.
I had a question. Okay, here it is. I'm there. It would seem to me that the natural, I mean, I don't want to say evolution, but the natural progression of life, as we move on, we are going to encounter a virus that is both very virulent and very deadly. How much does what we're doing now protect us against later? And the science is a big part of that. Human response, we'll talk about in a bit, how people react to this stuff, because that part's nuts. But how much of what we're doing now is really kind of setting the stage, because that day will come.
Yeah, for sure.
It's a logical conclusion to this, right?
Yeah, I mean, the hope is that this is a good trial run for when that day comes, and that we learn from all these mistakes, and therefore that day doesn't actually come. We nip it in the bud before it takes off. We never really know, right? That's the hope, is that we never know that was the virus that would have been the one that spreads as rampantly as this virus and kills as many as MERS, let's say 35% of the people. So the hope is we do learn from this and we move forward. I mean, something we were saying just before we started recording was the classic line of, those who don't learn from history are doomed to repeat it. So hopefully we do learn from this history that we're living to be better prepared. And that's really the key, is to make sure we are better prepared. So doing things like surveillance of viruses in the wild that have the potential to infect humans, really important. So there's loads of coronaviruses out there circulating in bats and other animals, many of which have the ability to infect human cells. If you put them in a lab, they can infect human cells. They don't necessarily grow very well or at all, but they can get into the cells. And that's the starting point, because then evolution kicks in and you can potentially select for viruses that would. So the more we know about the viruses that are circulating, the better prepared we're going to be, because we can look, oh, there's one person there. Isolate, get them away from anyone so that it doesn't spread. So surveillance is a key to dealing with this better. And then, of course, the other keys are to have a better arsenal of weapons to attack these with. So we may have talked about this last time, but if you think about bacteria and antibiotics, you can take the same antibiotic for a lot of bacteria. You don't need specific treatments because antibiotics are broad spectrum. We don't have anything like that for viruses right now. So every kind of drug treatment is very virus specific. So you get all your treatments for HIV, you get your treatments for flu, but they only really work on those specific viruses. If we could develop a broad spectrum that hits a lot of different viruses, that's a great thing to have for any new emergence of because viruses are all very similar. So all the coronaviruses are very similar. All of the flu viruses, there's lots of flu viruses, they're all very similar, but there's also similarities between coronaviruses and flu viruses. So potentially you can attack both with the same drug. So developing things like that, broad spectrum antivirals, makes us better prepared should we not nip it in the bud and it does start to spread. And then, of course, vaccines, again, as we're talking about, they're another key. So if we can, this is why I think I can speak for myself, and I think quite a lot of scientists are quite excited about these mRNA vaccines working, is because they're very easy to change. So as I'm saying, that mRNA is the spike protein of this virus, but it'd be really easy to change that to the spike protein of SARS-3, let's say. So if we can make these malleable vaccines, that allows us to respond much more rapidly. So then instead of this 1 year that it's taken, it may take 6 months to get a vaccine ready and to go into humans. So it's all those kind of development processes, learning from the mistakes we've made here, scientific. I mean, I'm talking here about the science stuff, not the social stuff. That's a whole different topic, but I'm sticking to my safe zone of the science. But it's those kind of things that allow us to be ready for the next one, in the hopes that we don't get SARS-3 in 2030. or if we do, we never really know about it.
Okay. Do you want to be a psychologist for a little bit?
I guess I can try with the disclaimer that this is going outside of my my realm of expertise, but I can try. I am a human, I guess.
Well, you know what? You're having a drink of rum there. Ma'am, you're a psychologist. There you go.
Don't tell people that. It's 9:30 in the morning.
Okay. Basically, what we're saying is this, is the first responders and the most exposed people are going to go first. And as we develop more and more millions of people taking this, we're going to find out if there are side effects. Now, the downside of that is we're going to have more and more millions of taking this. And anytime you do anything with millions of people, you're going to have something happen. So you have this door where you're learning more. You have this thing where you're learning more. But you're also opening this door to these anti-vax people who, are you familiar with I don't know how to pronounce this, the VAERS database, VAERS? It's an online vaccine response system that is completely online. There's no control on it. Anti-vax people use it quite a bit to promote, well, anti-vaxxing. And it's, you can go, I think somebody did this. You can go out there and put in a response to it that says, I took this vaccine and I turned into the Incredible Hulk. That's what it is.
Well, that sounds all right. Just find Thor, and then you can start the Avengers.
It does. But, that's the problem, is we're going to have this, we will discover more stuff, but we'll also have this stoking of fear. And we've seen that really used very well during this. And I guess let's touch on that. Are you familiar with the 1976 swine flu thing?
Yeah, briefly. I saw a few things about it yesterday, but I didn't have time to go fully down the rabbit hole of it, because obviously it's hard to get the good information in these areas because of the flood that comes from the disinformation of the anti-vax movements. So could you just recap just to see if I'm thinking about the right things?
Okay, 1976, two soldiers got ill in Fort Dix in New Jersey. And the concern was this was a strain related to the 1918 Spanish flu that killed 100 million, 400 million people around the globe. I don't remember which. The nation started this massive vaccinating program. By the time they were done, they'd vaccinated 45 million Americans. You think about that just by itself. And what they discovered was this increased the vaccine that they used increased exposure to, I always call this Guillain-Barré, and that's not the pronounced, it's French, Guillain-Barré. That's
Guillain-Barré. Yeah.
Right. Okay. So out of 45 million people, 450 people developed a rare neurological disorder, Guillain-Barré. And as other parts of that, anytime, if you had 45 million people take a drink of water, they're going to have some kind of effect. You know what I mean?
Yep.
There might have been 150 of them die tangled in their bed sheets, because that is a death statistic.
Right.
And I guess my fear with this thing is it goes on. Yes, you're going to learn more, but you also are open to the exploitation of fear. Because anytime you do something, something's going to happen. And human beings, we die. That's what we do. That's our logical conclusion to life. So that's where I'm going. Now you're the psychologist.
Well, so
tell us how we're going to deal with this part of this equation.
This is the hardest one to deal with, right? This is why I stick to just being in the lab with my cells and the mice and stuff, because they're a lot easier to deal with. But you're spot on. If you give 45 million people a glass of water, statistically, some of them are going to die. And this is the thing that it is hard to wrap the head around at times, is people don't necessarily grasp statistics and risk. And I wish I could remember the book that I'm thinking of with respect to this. I might have to look it up and email you. You can put it into show notes or something. But there's much writing about the fact that people don't understand or can't. It's really hard for humans to grasp the idea of relative risk. So if this vaccine, let's say vaccine X, let's not even talk about the coronavirus vaccines right now, but vaccine X let's say it has a severe adverse event it kills someone, let's say, at a rate of 0.0001%, in the total of America, that's going to come out to seemingly quite a high number of people. So quick sums, I guess it's going to be about 300 to 3,000. I forget how many noughts I used, but 300 million Americans, 0.0001%, that's going to be 300 to 3,000. And obviously that's going to hit the news of all these people got the vaccine, they've all died. Statistically, they've also got a 0.5% chance of dying in a car crash. Or so I'm just using hypothetical numbers here, but I'm kind of trying to illustrate a point that it's all about the relative risk. So vaccines are safe. They are incredibly safe. Millions and millions and billions of people around the world are vaccinated every year. And there's very few examples of severe issues with them. That's not to say there aren't. I mean, I'd be wrong to say that all vaccines are 100% safe, because that's just verifiably incorrect. But the numbers of those severe cases are so small compared to the number of people who receive the vaccines. The trouble is, it's easy to amplify those negative things. If you think about news cycles, they feed on negative news, right? If it bleeds, it leads, or whatever the line in journalism is. So then it amplifies, then it just hits that mindset of, oh my God, everyone's getting this death from vaccine. But that's only because that's what you're seeing. You're not seeing all the millions and millions and millions of people who are safe, and also all the millions and millions of people who aren't getting the virus. So now, to bring it back to SARS-2, let's say it's 1%, 0.5% of people who get it die. They're not dying anymore, and only 0.00001% or whatever from the vaccine. So it's about that managing the relative risk, but it's so hard to convey because it's hard to comprehend those kind of numbers. We just see the negative. We focus on the negative too much. It seems that's kind of my view. Sort of a bit rambly, but like I said, it's outside my comfort zone a bit.
One of the things I did to prepare for this was I had a conversation last night with my son. My rotten son, as my website knows him, because he attends the University of Minnesota and not Nebraska. He is in applied math, but his girlfriend is trying to get into med school. And she's the one that I had this conversation with. And she brought up something that really was a perspective. They're testing this on thousands of people. Millions more are going to take it. There are still people out there that say, I don't care, I'm not taking this. And I guess her response was, what else do you want them to do besides give it to massive numbers of people? What else is going to make you convinced that this is okay? And I think that, the answer for some of those people is they're never going to do anything. And I don't understand that mindset, I guess.
Yeah.
That's where you're the psychology again. You are a doctor.
I am just not a doctor of psychology, doctor of cell biology, but no, I mean, that's exactly right. So there is sometimes no getting through to people. If you take masks for an obvious example, the fact that people refuse to wear masks is still beyond me, because it's just a bit of cloth that goes over your face when you go into a supermarket or a restaurant or whatever. There's always going to be those people. We can try and we should try to get through to them all. But eventually, though, some people just won't take it. All we can do on the science side as scientists is try and put out the information, explain why it's safe, explain that it's been through the trials, explain what it means, which obviously is what I'm trying to help with to some degree here with you. Give out the good information, and then eventually it just comes down to people's own personal choice, right? It is just down to that their personal freedoms are whether they take it or not. And of course we want everyone to take it, and most people, I think if you look at the polls, most people want people to take the vaccine. They want to take it themselves, but at some point you won't. And this also, that kind of leads into the bigger idea about herd immunity. So when people talk about herd immunity, it's about getting as many people immune to a disease as possible to really mitigate its spread. The idea there is that there's always going to be a certain number of people that you can't make immune. either because they're immunocompromised or because they refuse to take a vaccine. So herd immunity always factors in for those kind of situations.
Okay, I kind of hate to go here, but I feel like I need to because, because I want to address this. Because you're a smart guy, you're a doctor, a cell biologist. I have someone in my life who insists that this thing was manufactured in the United States and sent to Wuhan. Okay? And they're like, because they don't believe that it just magically evolved from a bat or something. And I looked at them and I said, they said, well, it's biological warfare. And I said, how would you make a virus that only attacked old people because you thought they were a liability? How do you make a virus that goes after specific parts of the human race and not others? And how do you keep it from, evolving or mutating so that it doesn't kill everybody? And this is the kind of thing you watch a movie for. It's like James Bond type stuff. So as much as I hate to ask you, could you address that lunatic fringe? And yes, guy in my life, I called you a lunatic. But please, Dr. Weston, could you address that side of this?
Yeah, I mean, I'll address the specific one a little bit further, as you were doing as well. So if it was a specific attack on China, it's a really weird way to do it because they've got so much governmental power that they can lock down the whole country for 2 months like they did and completely stop it spreading while it's spreading around the rest of the world. So it's a really silly way to do it. But as a more general point, the amount of viruses in the world or on Earth is absolutely staggering. Again, I'm racking my brain to pull out the numbers. I think it's estimated that there are 10 to the power of 31 viruses on Earth. So that's 10, the number 10 followed by 30 zeros or 31 zeros. So then there's the things you can do where your average virus particle is 0.00001 of a centimeter, 100 nanometers. If you lined up all those virus particles in a line, they could span the Milky Way 2,000 times, something like. So it's just this staggering number of virus particles out there, and they are infecting all forms of life, as I was saying earlier. That they infect everything from humans to bats to whales to yeast that make beer and bread. They have viruses that infect them. There's viruses everywhere. So you're hitting almost an infinite number, as infinite as we can almost think, of viruses. So every kind of possibility can potentially happen almost. So the fact that the thought that this virus couldn't evolve in nature, when there's all of these possibilities that it could, is so minute that almost it's surprising it hasn't happened sooner. Right. Because there's so much complexity, so much diversity out there in nature that we don't know about. And the reason we're starting to find these things happen is because we're encroaching on nature more. Right. So the idea is that this virus was probably in a bat in caves in China. It evolved as a virus in bats, but there's similarities between humans and bats in the proteins that make us up. So it has the ability to get to humans. Chinese people farm the guano in bat caves for fertilizer, for farming and things like that. So they're going into the bat caves, they're exposing themselves, they're coming into contact with these viruses. And then that's how people can get infected. So it's that encroachment on nature, this almost infinite, limitless possibility of any combination of virus that could infect a human is probably out there somewhere. So just in sheer terms of numbers and statistics, it's so likely that it evolved in nature and it wasn't something produced in a lab. I don't know if that's necessarily the best argument to go against these things, talking about the numbers. But again, it's one of those where it's so hard to go through without directly talking to people, because people all have their own ideas about these things, right? And there's so many different ideas that you almost have to try and pick apart each one in turn. So I'm trying to give that big overview of there is almost an infinite amount of virus out there. So there's an infinite probability or possibility that they could infect humans, and that's exactly what we've seen.
I think as a amateur psychologist myself, that the need for people to invent boogeymen, because inventing boogeymen is easier for them to comprehend than the uncertainty that is the world we live in. That is forever astonishing to me, where we can't deal with chaos, so we have to organize it into James Bond villain creating viruses, I guess.
Yeah, no, that's a great point, and that really is the case. And a line that was often said during that period where there was a lot of debate about whether this was lab made or it came from nature, which has sort of died down, and I've not really thought about it a lot recently myself, but it was a line along the lines of Mother Nature is a lot better at this than we are and than we could ever be. So while we know a lot about how viruses work, there is no way we could make something like this. To what you were saying a minute ago, there's no way we could make sure it only kills the over 65s and leaves the rest largely unscathed. There's no way we can design it to spread asymptomatically like this virus does. It has that asymptomatic spread, what we're talking about. We don't know why that happens. We have no idea. So the thought that we can actually make something do that is, I mean, it's a thought, but it's so far outside the realm of possibility. There's so many fundamental things we don't understand about viruses, which is why I have a job, for example. That right. Yeah, it's one of those that it's going to hang around, to your point, because boogeymen get invented, and it is a psychological feature that it will stick around with us for a while. And I guess the best thing is just to keep trying to dispel it and explain the science and explain the facts about everything, because there is misunderstanding of what viruses are in many places. And so just the more information we can get out, I think the better.
So back to the viruses for a minute. Both of these, the prominent two that we've discussed, one of them requires negative 70 degrees Celsius to be transported and to store, which sounds like a logistical nightmare to me, especially if we're talking about Madagascar, right? I don't, maybe that's an insult to the people of Madagascar, but more consider it my ignorance of what Madagascar is like. But it seems that we're going to be months and months and months before you and I get to take this vaccine anyway. Do you see anything happening over the next few months? This thing is exploding now again. We're going back into some lockdowns. What's going to happen over the next few months, you think, until this is widely available?
Well, so in terms of that, the temperature storage, so that is the Pfizer-BioNTech vaccine that needs the minus 70 to minus 80 Celsius, which is 4 times cooler than your freezer you have at home, just to do the conversions for Celsius and Fahrenheit to make that clear. But so that needs to be stored that cold. What Pfizer are trying to do is source freezers that can keep things that cold, but they're also looking into technology that's essentially a cooler box that they can keep at minus 80 for about 10 days. So that's how they're trying to get this distribution going. So you have your minus 80 freezers in, let's say, South Africa, one of the more built up areas in Africa, and then you can distribute these cooler boxes to other places. Just to use your example, you can get it out to Madagascar within 10 days easily enough. So there are ways around it. Moderna's vaccine has the advantage that only needs to be kept at minus 20 Celsius. So that's really good news for Mrna, much easier because you can just keep it in the type of freezer you have in your house. So that was why it was really great to see Mrna coming out with similar efficacy numbers to what Pfizer were saying. So moving forward in distribution, I think what we're going to see is, as I say, Pfizer have put in their EUA, emergency use authorization, with the FDA as of today. I think I read it this morning. But I was just waking up when I read that, so I might be wrong. I thought I read that when I was that groggy-eyed first thing in the morning. But they're going to put it in the coming days, if not already. Mrna need a little bit more time. They need to hit their 164, 170 people, as Pfizer did this week. Then they'll do the same. So those authorizations, they'll take a little bit of time. The FDA have to assess all the data. look to see if it's all true, what Pfizer have reported in their press releases and Moderna have reported, make sure it all looks good, and then they'll potentially give the emergency use authorization. Both of those companies can then start to distribute their vaccines outside of trials. So those 50 million and 20 million doses I was talking about, they'll start to be going into people by the end of this year. I'm hopeful in the next month or two, we may start to see similar data coming from other vaccines. So I think it's nearly 10 vaccine. I think 9 vaccines that are in phase 3 trials. I could be wrong on that. I can think of about 3 off the top of my head, but I think there's many others that are similarly in phase 3 trials. So they're doing the same thing that Pfizer and Moderna are doing. They're just waiting to get their positive cases to see how effective their vaccine is. So, for example, the Oxford University AstraZeneca vaccine, that's in phase 3 trials. That had to have the pause because there was a death in the trial. I think possibly 2 pauses, if you remember seeing those headlines. Right. Turned out both cases, that was nothing to do with the vaccine. That was just, as we were talking about, someone who died wrapped up in their bed sheets, right, or whatever it was. So they had to pause, which obviously puts a slowdown on all of their trial, which is why they're a bit delayed compared to the others. But in the next few months, we'll start to see more companies putting out their data from phase 3 trials and then start to apply for the same kind of emergency usage agreements. So then they'll start to go into people. With Pfizer and Moderna, who are obviously a little bit ahead of the curve, they'll be using it in this emergency usage. The more and more people that use it, the FDA get more and more data to make sure it's safe, make sure it's working, and all those kind of things. Then they can move it towards full approval. So this, again, about the safety, this is going to be continually assessed for the whole time it's being used. If anything starts to appear that's a negative consequence of this vaccine, the FDA will halt its usage until they can work out what's going on. So they're going to keep looking at it through all this period while it's being given to more and more people through the early part of next year. Again, on that prioritization of healthcare workers and things like that. Assuming all that's good, then they approve it. The companies can ramp up their production, ramp up their distribution, because the EUA has a limited distribution level. So you really ramp it up. Then more vaccines come in behind following the same trend. So I really think that the numbers that we're talking about, 2021, that's when we'll have vaccines going into people. And by the end of 2021, it may be widely available to the public, or well, maybe available to the public, just not very widely. But of course, if we get,
you should say the fall of 2021, so we have a whole college football season.
There we go. Well, it's it's possible and it's promising. So we're talking about the numbers earlier about how the number of doses that Pfizer and Moderna have promised add up to just over 1 billion people. Let's say that the AstraZeneca Oxford vaccine can do a similar amount and is similarly effective. That's then 1.5 billion. Let's say Novavax's vaccine. So Novavax is a company in Maryland that we've helped a bit of their development with. So that's just why they come to mind. If they can also do another 500 million, that then hits 2 billion people. So now you're starting to get really wide availability of these vaccines. And I say vaccines because it's different ones, and you get to take the one you like the most. Let's say you've got stock in Pfizer or Moderna, maybe you want to take that vaccine because it's the one you've got stock, or some whatever choice you decide to make, or if it's geographically available. Maybe for me it's the Novavax one, maybe for you it's Moderna. So that's sort of where I see this going. There'll just be this gradual uptick in the amount of vaccines available, an uptick in the amount of people who have it, continual assessment of the safety of these and the efficacy. And, optimistically, we start to see this pandemic come under control.
That would be nice.
Right. And we have to, as well, I'll stress as well that we have to keep doing all the other things that we are doing now while that's all happening. So just because we have vaccines going into humans doesn't mean this is over by any stretch of the imagination, because obviously it's going to take time to vaccinate all the people. So we still need to keep doing face masks, physical distancing, just being sensible, trying to be outside as much as possible. And this is, it's been referred to as the Swiss cheese model. I don't know who first came up with it, but I've seen it floating around, and it's a great picture where it has You can find it on Google if you search Swiss cheese model coronavirus or something like that. So it has the layers of Swiss cheese all with their holes in, and then the virus that can sort of go through different levels of the holes. But the more you have and the holes aren't all aligned, you're eventually going to stop it. So you've got your mask, your physical distancing, your being outside, then your treatment, then your vaccines and things like that. So the more and more layers of protection, that's how we get this under control.
That I like that analogy.
It was great.
That
I wish
guy
I
was
could.
a really smart guy. Was he a scientist or a psychologist?
I got no idea. I just saw it floating around on Twitter one day. I really wish I knew who had originally come up with it, but so I could give the credit to him or her, whoever made it up, because it's a perfect analogy for why we need all these different layers. Because it is about making sure the holes don't all align, because it can get through certain levels, but it can't get through them all.
You know, while you were talking about the different vaccines, I was thinking that maybe we should turn this into some kind of team sport, like the EPL, you know, where I'm on Team Mrna. I don't know. That sounds kind of silly.
I don't know. Team partisanship and team affiliations, they do count for a lot. So it's not necessarily a bad way to get it rolled out.
I don't know, maybe it would counter the people that are all like, I'm never doing this. I'm never going to touch this.
We should
Bill
get all
Gates
the teams
is putting microchips in us. That doesn't even anyway, we won't go there.
Well, to say on that one, says the person looking it up on their iPhone that tracks exactly where they are all the time, right? It's but no, Bill Gates is not putting microchips in them. Bill Gates is helping development because he's got a lot of money, but let's not even go there.
Is there anything else you'd like to add?
Well, I was just going to say what we should do on that part, the team things. We should get all the teams sponsored by a different vaccine company. Right, so you've got Moderna on your Nebraska shirts, and then Maryland has Novavax. Right, that's the way to go.
At least it would be fun.
Right. I think we've covered all of the bases, really. The main things I wanted to get across while we were talking was sort of an understanding of what the vaccine is and why it's safe. The fact it's just that one protein of the virus. There's nothing that can cause damage that the virus couldn't cause itself to a much higher level. So it's a really, really stripped back just to one little unit of the virus. They seem to be super effective from what we're seeing so far. They're going to be continuously monitored for the safety. It's just because it gets approval for emergency usage doesn't mean everything's fine. It's going to continually be assessed. The people who are getting the vaccine are going to be followed. The people in the trial are still going to be followed for a year or 2 years. So if anything comes up, that's going to be found. That follow-up is important because that's how we learn how long-lived the immunity is, and then whether we need to vaccinate every year or not. And then finally, the fact that just because we're getting vaccines doesn't mean this is over. That we still have to do mask wearing, we still have to physically distance, and still have to be sensible, because it's going to take time for these vaccines to get around everyone. And those are kind of the main things I wanted to convey today.
It's a lot. I mean, it's for a guy that I no idea what RNA is. This is a lot to take on. And I guess when you go out and read the media articles, you're constantly confused by, I'm going to the fake news stuff. I don't agree with that. Therefore it's fake news. And I don't know what to believe or what not to believe. Oh, this came from that paper that wrote that other article. And it's mind-boggling the amount of confusion that goes into this stuff. Even though we have the internet, we have the entire world pretty much connected. For all those people that are, I realize this pandemic is upsetting and it's difficult. We're still in the best time to be alive in human history. There's less poverty throughout the entire world. There's less war and violence throughout the entire world. There's less disruption. I realize that there's more uncertainty right now because of this virus, but this is a damn good time to be a human. The climate, we could argue about the climate, but you got to give and take. So
yeah, I mean, just read some of the research from Steven Pinker, or his most recent book that lays out all those things. If you've not come across it, he made a great book basically explaining why this is the best time to be alive. Just to exactly the things you're saying for all those reasons.
Well, all it is. I guess you can choose to stay positive, or you can, and honestly, the people around you can be toxic, more toxic than a virus, and drag you into this hole. And we could go on. There we're being amateur psychologists again.
Yeah, let's try and end on a positive note. Let's go for a positive ending, shall we?
Well, is there anything positive you'd like to end with?
Well, I mean, I guess just that we're getting closer to having vaccines. That's super positive news and amazing scientifically, because this has just been pedal to the metal science production, getting these vaccines tested. The people volunteering to go into these trials are absolute heroes. The companies doing it all, and of course the heroes on the front line having to deal with this while we're producing the vaccines. So, I mean, there's great humanity out there. I guess that's the positive I'll try and end on. And we're getting closer to getting this under control with these vaccines, and people, if we keep doing the masking and the distancing, we'll hopefully get this under control next year. I think next year will be a lot more back to normal. I think you'll have a football I'm hopeful you'll have a more capacity football season, let's say. Maybe not 100%, but I think you'll be allowed more fans.
Well, we'll probably follow up with you in a few months and see where things are. All right.
Yeah, very happy to talk to you.
This has been John's Post-Life Crisis, talking about vaccines with Dr. Stuart Weston. Thank you for listening, and go Big Red.